Oh, hey there. How's it going? I have something to show you guys. Just give me a minute to get it ready. All right, ready enough. It's the fourth time's a charm, right? You guys ever went to the store and found something that you knew you didn't need, but you looked at it and you're like, damn, I have to buy this? I think everyone's done that. I do that quite often. So I went to the surplus store where they sell all sorts of stuff like this, a DC motor with a gearbox and a wheel, and the tread is an O-ring. And, I found this and I looked at it and I was like, for 10 bucks, I have to buy this. As a matter of fact, I had to buy two of them because I knew exactly what I was going to build with this when I saw it. I'm going to build a balancing car. So you guys have probably seen these balancing car things before. They're actually pretty common. A lot of people have built them. You've got two wheels, some sort of frame, and then a battery, a DC motor controller, a gyroscope, and an Arduino board in my case. And you basically use a PID loop to make the thing not fall over. So that's the goal of today's project, is to make that work, I guess. So the first thing that we had to do was design a mount for these wheels, which I've already done. And I just have to put this other mount onto this wheel, like so. All right, so now we got two mounts, two wheels. Now, if we only had a frame to attach these two wheels together. Oh wait, it's already here, it's right here, we've already got one. Okay, so we just got to attach this to this wheel and then this to this wheel, and we'll have a frame. So we already have this frame, but looking at it, I'm realizing that I also have this frame, and this frame is taller, which means that it's better. I'll show you why it's better in just a second once I get the battery mount off of this frame. Like I said, I've done this a few times before. So the advantage with a taller frame is the same advantage as it is balancing a stick on your hands. So it's going to be much easier for me to balance this taller section with a lot of mass in the top of it than it is for me to balance this little frame with no mass at the top of it. And this holds true for a lot of things. If you're trying to balance a stick in your hand, that a really long stick with some mass at the top is actually easier to balance than a short one, because the reaction time can be so much slower and you could still make corrections for errors. So I made this larger frame with a compartment for a battery, which I now realize needs to be two batteries, so I'm gonna have to make another frame. That'll come later, that's still in the 3D printer. And then I've also got a place to mount my DC motor driver. Now I haven't checked to see if I've got the spacing right for this, and it looks like it's close enough, so I can go ahead and bolt that down. Guess I could show you guys what I'm doing, huh? I'm just putting some 3mm screws through the circuit board and into the plastic. I mean, through holes in the circuit board. I'm not making my own. Okay, so now we have a battery and a DC motor driver. Now we need two more things. We need an Arduino and we need a gyroscope. The gyroscope will probably come last. For now, I'd like to bolt these wheels onto there and see how fast it moves. So let's give that a try. Now this is going to be a non-balancing test. This is going to be an assisted balance, you might call it. It's actually not... It's more like an assisted drive than an assisted balance, I guess. So I'm just going to put... Well, there's another problem we have to fix for version 2. Unfortunately, that's going to have to be version 4, because version 3 is printing. Yeah, okay. Well, you live, you learn. Alright, so we've got one wheel bolted on. I'll probably go and make that change so the battery can't slide out the side before version 3 even finishes printing, because it won't do me much good if the battery's going to slide out that easy. Alright, we have two wheels, we have a battery. Let's see what's going to hit the ground. Oh, of course, it's going to be the battery. Let's hope there's nothing sharp around. All right, so now I want to make a temporary connection to my battery from my motors, just for the fun of it, I guess. So let's try to manage that. Already stripped back my wires. Oh, there we go. That was easy. Ta-da! That seems a little slow, doesn't it? You guys think that should go faster? Because, like, oh, if it's going to have a hard time correcting at that little bit of speed. See, that's why I thought it would need 2 batteries. How do I test it with that other battery? That's going to be hard. You know, I have to make a wiring harness for the batteries anyways. I could just do that now. Yeah, let's do that. All right, so disconnect. I've got some connectors for the batteries. I don't know if there's a way you're supposed to solder to these, but I tried to take one of these apart the other day. Or maybe there's some way that you're supposed to connect to them. I don't know. I'm just going to try to solder in the cup, I think. This clearly isn't going to go wrong at all. Okay. We're going to have to find a different method for holding that. When in doubt, get the vice grips out. There. And we have a positive. Okay. So now our negative is going to have to go to the other positive, but it's also going to have to power our Arduino if we're going to have full voltage to our motor controller. Our Arduino can only handle, I think, 12 volts on the volt V in pin. So we will go negative from that one to positive of this one. So we have 2 batteries in series. So that would be this side. We will strip. Oh, wire's good. I will pre-tin this wire. I didn't before. Probably a good idea. Oh, no. Okay. So negative to positive. And that will give us series connection. All right, and then we need another negative wire. Now for our actual negative on the negative terminal of this battery. All right, and we've got those connected. So now we should have just under 24 volts between these 2 batteries. Let's see if I can get them both to stay in this frame the way that I'm hoping I will. Aha! Great success. Okay, now I need some wire nuts. Oh, I know where I have some. Now I tested this the other day. Because these motors are mounted opposite to each other, I need to wire the motor's polarity opposite. So black to black, red to red, red to black for the motors. And then with this, I'll just hook red up to whichever one because it doesn't matter which way it goes. I just want to see if the motors die at 24 volts, I guess. You know, if they did, that would actually really suck. I'd have to go back to that store and hope that they still have these motors. Ah, who am I kidding? Nobody else would buy these. All right. Now we have two motors wired to two batteries that are wired in series. So if I short these two leads, we will get 12 volts, right? So that's what it looks like driving with two wheels on 12 volts, or 11.1 technically. That could work, but let's see how fast 24, or what would that be, 22.2 volts is. All right, that's 24. And this is 12. What do you think we should use? 24. I think we should use 24. All right. So now we need to get an Arduino board on here. We need to get some programming on it, get a PID loop and a gyroscope, and I'll build another version of this frame that has a spot for another battery so that we don't have to worry about that happening. Okay. So since I'm waiting for stuff to 3D print, I've moved on to the next step, which is the Arduino part. I am actually not in the business of doing Arduino tutorials, and for that reason, I'm leaving most of this out, other than the fact that I just happened to find an MPU 6050 accelerometer, gyro, and other thing laying around. And I've been calling it a gyro the whole time, but really what I'm looking for is, I think, the accelerometer in it. It's an IMU. So now if you look at the serial plotter window that I have open and see how I'm moving the gyroscope, you can see that each way that I move it is a different axis. So if I tilt it this way back and forth, the blue line moves. If I tilt it this way, the green line moves. If I could keep it straight in the blue direction. And if I tilt it this way, the red line moves. So that's telling me which direction the gyroscope or the accelerometer is moving. So the only one that I'm going to care about, depending on which way I mount this, is going to be the blue line. So I'm probably going to want it mounted this direction. And that's all I'll need to know to control this car properly. So yesterday is today, and today is tomorrow, I think app says, or maybe it's day 2, hour 0. Either way, about 2 a.m. last night, my frame version 3 finished printing, which had 2 slots for the batteries. The only problem is that when I peeled it off the build plate, I broke it right in half, which is unfortunate. But the good part is that I was not too sleepy, and I was able to make a version 4. Although with the version 4, I did yet again forget to add sides to this to stop the battery from sliding out. But that's actually not going to be as important as I thought it was, because if you realize the car can't tip this way or that way, I mean the only reason it would is if you're moving it like by hand. So the battery isn't really going to want to slide out those ways. It's only going to want to fall out this way or this way. So we're going to be fine. Let's just test this out. Grab 2 batteries. Oh, and I made my Velcro hole bigger so that the Velcro can go through there the right way. Yeah, that will work just fine. So the car's only going to go this way and this way. And that is a lot of weight, actually. Okay, yeah, that's going to work out really well. Now we have to attach it to this, to these wheels. Alright, well, it seems to be balancing quite well already. No electronics at all. So I'll put these batteries in here, see what that looks like. Quite good. That looks quite good. Okay. Now we need to install the Arduino board and install this accelerometer. That's what it is. So I think I'm just going to hot glue these 2 things in there. And while we are waiting for that to warm up, we could start wiring up this speed controller. so we've got positive and negative for one motor. Go ahead and hook that in. And then positive and negative for the other motor, but reversed. Can't remember what VD and VS stand for. Okay, so the VS marking on here, that's the supply for the motors themselves. So that's going to be the full 22 volts. So we're going to go right from the positive of the second battery in series. Yeah, the second battery in series. Just going to shorten this wire up a bit. And supply that with the full 22 volts. And for the ground, we'll go with the first battery in series. Oh, I can smell our hot glue guns ready. Hot glue the circuit board down somewhere. And then hot glue the accelerometer down. Damn, that's hot. E1, M1, E2, M2. Gonna need to mix this ground with a ground to the Arduino. We gotta find some jumper wires that are male to female. And those are the ones that I'm least likely to find. So, found some. Alright, so let's go from one. I think I can PWM any digital pin. Alright, so I had to double check and see what the voltage source for Arduino Mega is, and that would be 7 to 12 volts is what they recommend. And that's exactly what I've got, 11.1. So this first battery will power the Arduino. The second battery is in series with that one and will power the microcontroller. So let's see if the microcontroller boots up or blows up. Either way. Alright, it booted up. Didn't blow up. That's good. That's good. So the all of the motors on this thing should not be active until I get the enable pins pulled high or low. Alright, so I think the first goal with this should be to test the drive output on the motor. See if this thing will actually move. So we have got it measuring the angle from this accelerometer. Now we just need to know if these wheels will move when I do the things that I think I need to do. So if I do setup, first thing I have to do is set all of these pin modes to outputs. Here's an idea. Let's just take that value from the accelerometer and write it directly to the motor controller. Oh, hey. Oh shit. There the smoke came out. Oof. Yeah, I definitely burnt something up there. Yeah, I'm guessing that was the oh. This jumper right here, the instructions mentioned, do not install this jumper unless you're going to have the same voltage supply as you do for the control. Otherwise you burn out the circuit on the motor controller. They didn't warn me, though, that it came with this installed from factory, so when I tried to plug in the voltage source... Oh, the circuit trace burnt! I could fix that. I could totally fix that. I can make this work still. Alright, let's do that. See that? Even though I really, really screwed up, it's not like that bad, because I can fix these traces. I could fix those. So all I need to do is jump VD to that pin. So if I red to VD, hey, we got a light. Let's see if it works. Alright guys, I wrecked it. I can't fix it. I'm pretty sure I've blown the microcontroller on my motor driver. It was a pretty stupid mistake to make. I should have pulled this jumper off. I didn't. The cause was I not only shorted out one of my lithium batteries, which I should have had a fuse for, but I didn't. but I also over voltaged my motor controllers, control circuitry. So that's blown. I'm going to have to buy a new one, and I'm going to do that. And as soon as it gets here, I will continue this video. But until then, thank you guys for watching. We'll see you next time.